Hello everyone, today we're looking at Unit 6, Lesson 4, Primary Trig Ratios, Solving for a Side Length. So in the previous lesson, we worked on solving for an angle. In this lesson, we're going to work to solve for the side length of a triangle. We're going to start out with what are the primary trig ratios for angle M? And I'm just going to write that acronym we learned in the previous note to help us. SOHCAHTOA. Okay, so we've been given our given angle of theta. We can label our side lengths as they relate to that angle. Our hypotenuse is always across from our 90-degree angle. Our opposite side would be KL, and our adjacent side is that side that's next to our angle. Okay, so the sine of theta is going to be equal to opposite over hypotenuse. The cosine of theta is going to be equal to adjacent over hypotenuse. And the tangent of theta is going to be equal to opposite over adjacent. So if we wanted to fill in some information with this, well, we could say the sine of theta is equal to our opposite side, which we don't know right now, so we'll just leave it as a question mark. But we do have our hypotenuse. Our hypotenuse is 7. For our cosine of theta, our adjacent side is 6.7, and our hypotenuse is 7. And then finally for the tangent of theta, that's going to be our opposite side, which again, we don't know, over our adjacent side, which is 6.7. So if we're trying to find angle M, which is our theta in this case, we can't do it if we have two missing pieces of information. What I mean by that is if you look at the sine, we don't know what theta is, and we don't know what our opposite side is. If you look at tangent, again, we don't know what theta is, and we don't know what our opposite side is. So we have too many missing pieces of information in this. But with cosine, okay, when we look at cosine, the only thing we don't know is theta. So we do know how to solve when there's just one unknown variable. So let's say we can only use cos because adjacent and hypotenuse were given, right? We were given those sides. So then we're able to use cosine to help us solve for angle M. So we would say that the cosine of theta, or M, is equal to 6.7 divided by 7. So we learned in that last unit we could take the cos inverse to isolate theta. And we should get that theta equals 16.8 degrees. So we can say therefore angle M is 16.8 degrees. How can we use M to find our missing side? So now that we have angle M, can we use that somehow to find our missing side, which our missing side in this case, right, we could call this lowercase m, right, because it's opposite angle M. So let's call that our opposite side, or M. So we're going to sub the fact that angle M is equal to 16.8 in for theta and solve for our opposite side. And in this case, for our opposite sides, we can use sine or tangent. Okay, so we're going to first do it with sine, and then we'll do it with tangent. So for the sine, well, we know that the sine of theta is going to equal my opposite side, which is M, over my hypotenuse, which is 7. So I'm going to sub in that 16.8 I found for theta and see now if I can figure out what M equals. So similar to when we were talking about similar triangles, we can just cross multiply. I'm going to write the sine of 16.8 over 1, because remember, every number has a denominator of 1. Okay, it's just kind of like that invisible math we've talked about. And I really write that there so that we can see what we can cross multiply with to solve. So I'm going to cross multiply. So 1 times m is just going to be m, and then we'll have 7 times the sine of 16.8 degrees. So if you do m times the sine of 16.8, you should get 2.0. Okay, let's take a look at that with tangent as well. So if we did the tangent of theta is equal to my opposite side, which is m, over our adjacent side, which is 6.7, we'll again sub in 16.8 degrees for theta. And again, I'm going to put tangent over 1 so that we can cross multiply again. So m times 1 is m, and then we'll have 6.7 times the tangent of 16.8 degrees. And you should get the m equals 2.0. Like you saw in the previous days, no, it doesn't matter which trig ratio we use, we should get the same answer. For both calculations. So we're really going to take a look at how can we continue to basically sub in our given angle and sub in one of the sides and then use algebra to find that unknown side length. So let's give this a try with a few examples. So our given angle in this next example is 22 degrees. So we're going to use that as our reference angle, right? We'll call that theta. And then we have to label what sides we're working with. It's wanting us to find the indicated side, which it's calling x. So that indicated side in this case is our opposite side. And they've also given us our adjacent side. So we have opposite and adjacent. And again, I'm going to write SOHCAHTOA. So which trig ratio uses opposite and adjacent? That is tangent. So let's use tangent in this case to help us find the unknown side. So remember, the tangent of theta is equal to our opposite side over our adjacent. In this case, we have our theta is 22 degrees. Our opposite side is x, and our adjacent side is 7. So I'm going to put that over 1, and then I'm going to cross multiply. So I'll have x times 1, which is x, and then we'll have 7 times the tangent of 22 degrees. Okay, 7 times the tangent of 22 degrees is 2.8. So that would be your side length. Okay, let's try another. Okay, this time our given angle is angle B here, so I'm going to call that theta. Okay, they're asking us to find x, which x in this case is our hypotenuse. And then we're also working with the side across from our given angle, which is our opposite. So we have to take a look at which trig ratio uses opposite and hypotenuse, and that's going to be our sine. So the sine of theta is equal to opposite over hypotenuse. So we have theta, it's 28 degrees. Our opposite side is 5, and our hypotenuse is x. So again, we put this over 1, and we cross multiply. So we'll have x times the sine of 28 degrees is equal to 5 times 1, which is 5. Okay, now I need to isolate x, so I'm going to divide both sides by the sine of 28. Right, so then they cancel out. So then if you have 5 divided by the sine of 28, you should get 10.7. So this is kind of the big takeaway, is that whenever we're given a triangle and we're trying to find a missing side, we have to decide which trig ratio are we going to use based on the side lengths that were given to us, and then plug into that trig ratio and cross multiply to determine what the unknown is. So our last example today is we're going to solve the triangle for all missing sides and angles. Okay, so all missing sides and angles. Well, what has been given to us? We have side E, we don't have side D, and we don't have side F, and we also don't have this angle here, angle E. So I'm going to suggest that's where we start because that's the easiest mathematically to do. So let's find angle E. Okay, and that's just a matter of the sum of our interior angles. So we know that all three angles have to add up to 180. So we're just going to subtract from that the sum of the angles we already have. So we know we have a 90-degree angle and we have a 50-degree angle. So 180 minus what's in our brackets there, so that's 140. So angle E is going to equal 40 degrees. Okay, so I'm just going to write in this 40 degrees. Okay, now for the next part, we're trying to find either of those two sides. So we're going to call this our theta because it was our given angle. And then we can work towards, let's try to find side D first. It doesn't matter too much which side we decide to find first, but let's find side D. Okay, so if we're talking about side D, right now we know that side D is our hypotenuse. Okay, and then we have to look at what other side do we have to work with here. Well, we have the side next to our given angle, which is our adjacent side. So if we have our adjacent and our hypotenuse, that tells me I'm going to use cosine, right? Because cosine is adjacent and hypotenuse. So we'll have the cosine of theta is equal to my adjacent side over my hypotenuse. And then we'll plug in our information. So theta is 50 degrees. Our adjacent side is 9. And our hypotenuse, I'm just going to use that lowercase d to represent that. I'm going to put that over 1 and I'm going to cross multiply. So I'm going to have d times the cosine of 50 degrees is equal to 9 times 1, which is 9. And then I'm going to divide by the cosine of 50 to isolate d. So you should get that d is equal to 14.0. No units on this one, so. Okay, and then the last one, let's try to find f. So if we're wanting to find f, well, we can see that side f is our side that's opposite my given angle. So if we have our opposite side, and we have already been given our adjacent side, which trig ratio are we going to use now? Well, that's opposite and adjacent, so that's going to be our tangent ratio. Okay, so we'll say that the tangent of theta, oh, actually, before we do that, let's just write what we're finding to stay consistent. So we're going to find side f. So we decide we're going to use the tangent of theta is equal to opposite over adjacent, and then we'll plug in our information. So theta is 50 degrees. Our opposite side we don't have right now, we'll say is f, and our adjacent side is 9. So we'll write that over 1 and we'll cross multiply. So 1 times f is f, and then we'll have 9 times the tangent of 50 degrees. And you should get 10.7. There was another triangle equation that we've learned back in analytic geometry that you could have used as well in this last step. Once you have two sides of a triangle, to find the third side of a triangle, you could use, and I hope some of you remember, Pythagorean theorem. But remember, we need at least two sides to use Pythagorean theorem. So it wasn't until this kind of part 3 that we could have used Pythagorean theorem. But I wanted to make sure we practice using our trig ratios. But we'll get some practice with Pythagorean theorem in future lessons. But just a reminder to kind of jog your memory on that one. Okay, that's all for your note for today.